Hello students, welcome to our video on isotopes. In this video we're going to learn how to identify isotopes. We're going to learn about isotope notation and isotope percentage. So please take out your notebook so you can start taking notes. And I like to begin talking about isotopes using the jelly bean example. Suppose you have a bag of red jelly beans. Is the mass of every single red jelly bean the same? No, right? So all jelly beans will have a different mass because they're not identical. And now imagine that instead of jelly beans, these are atoms of carbon. Is their mass the same? And the answer is no. The mass is not the same. The mass of every single atom carbon will be different. Now, we already talked about isotopes on the last video where we talked about what happens when we change the number of neutrons. So probably this will sound very familiar to you. Let's begin with here the first one. Atoms of the same element have the same number of protons and electrons if they're neutral, but each of them will have a different number of neutrons. Because they have different number of neutrons, they also have different masses. Remember that the neutron has a mass almost equal to that of the protons. So both protons and neutrons will be the particles, the subatomic particles that we have in the nucleus that will have a mass. The electron mass we don't consider for this. Atoms that have the same number of protons but different numbers of neutrons are called isotopes. This will be our definition for isotopes. And the atoms have to be of the same element, of course. Here we have three examples of isotopes. We see the first one is a carbon-12 isotope. It's an isotope that is stable. So it's the same case with carbon-13 is also stable. However, carbon-14 will be an unstable isotope and this will be radioactive. We also talked about radioactivity in the last video on what happens if we change the number of neutrons and protons. So now that we know the definition of an isotope, let's keep on going with the isotope notation. So this is how isotope notation or isotopic notation would look like. We would have the element, and in this case we only have one letter, but remember that the element can have two or three letters. So we would have the element, and then the number on the bottom left will be the atomic number, and remember that the atomic number states the number of protons that this atom has. Then on top we will have the mass number, or the atomic mass, and the mass number represents the protons and the neutrons together. Now don't make the mistake and think of the mass number as just the number of neutrons. It also includes the number of protons. So it's both of these subatomic particles together. Here we have another way to write isotope notation. In this case, we see that we have a third number right here, and this is isotope notation with net charge. So again, the atomic number will be on the bottom left, and then we have the mass number right here on the top, and this new number will be the net charge. In this case, we're talking about magnesium. We see the element symbol with atomic number 12, mass number 25, and a net charge of positive 2. Now if we try to determine for this same isotope, if we try to determine the number of protons, neutrons, and electrons, this is what we would have to do. For the number of protons, we know that we have to use the atomic number, so that will be 12. That's pretty straightforward. So we have 12 protons in here. Then for the number of neutrons, what we have to do is we have to use the mass number, which tells us the number of protons and neutrons, and to that number we have to subtract the number of protons. So we have to do here subtraction 25 minus 12, and that will be equal to 13. So we have 13 neutrons in this example. Finally, to determine the number of electrons, we have to take a look at the net charge. The net charge states that we have a positive 2 on this atom. That means that we have 2 extra protons. So if we had the same number of electrons, suppose we had 12 electrons, the atom will be stable, and this this positive 2 will not be here, but it's not the case. So that means that we have 2 extra protons, and 2 electrons flew away, so we no longer have 2 electrons here. So 2 electrons that are gone gives us a number of 10. We have 10 electrons in total. So the numbers will be 12 protons, which we get from the atomic number, 30 neutrons, which we can obtain from the atomic mass, subtracting from this atomic mass the number of protons, and finally the net charge will tell us information about the number of electrons that we have in the atom. Now let's do it the other way around. Let's try to solve a problem where we have the number of protons and the atomic mass, and we have to write this in isotope notation. First thing we do is we take a look at the number of protons, and we have 18 protons. Now we have to use a periodic table to find which element contains 18 protons. We go to the periodic table and we see that argon would be the element that has 18 protons. So that's the element we're looking for, and we're going to use the symbol AR. So what I'm going to do now is write the symbol AR, which is argon. Then I'm going to use the number of protons for my atomic number. So 18 will be right here in the bottom. And then the atomic mass 40 will be up here. And that's it. So that's my isotope notation. Now, if I want to take a step further and I want to know the number of neutrons that I have in this isotope, then remember that we have to subtract 40 minus 18. So in this case, we would have the number of neutrons, if we want to find it out, will be equal to 14 minus 18, which is 22. So we would have 22 neutrons in this isotope. And because we don't have any information on the net charge would be 0, and we're talking about an electronically neutral isotope. The number of electrons, therefore, will be the same as the number of protons, so it will be equal to 18 in this case, because we didn't get any extra information on the net charge, so it should be 0. Otherwise, we would have here some information that we could use to write down the net charge for the isotope. Now let's relate the isotopes with the atomic mass. Because there are many isotopes in the universe, scientists calculate the atomic mass of an element based on the average mass of the different isotopes. And the atomic mass number that you find in the periodic table is actually an average of the different isotopes that scientists have measured in order to calculate this number. So we have things that are, we have like an average atomic mass, and we also have that isotopes will have a percent abundance. So the isotopic abundance for certain isotopes will be greater than others. Now, in the second part of the video, we will have problems on how to calculate atomic mass, the average atomic mass, and isotope abundance. So this was part 1, and later on I will post part 2 of this video on how to calculate isotopic abundance and average atomic mass. So I'll see you later.